Alright guys, you are welcome back to my channel. In this part now, we're going to be solving this problem that says find the fifth root. Alright, we're going to be solving this problem that says find the fifth root of z equal to 12 into cos 300 degrees plus I sine 300 degrees. First, I want you to understand that this is a complex number already in polar form. And now we are asked to find the fifth root of this complex number in polar form. And of course, again, I also want you to know that this question is under the concept of nth root of a complex number. And the formula for tackling such problem is that the nth root of a complex number z is equal to r raised to power 1 over n into cos, let me use a square bracket here, into cos theta plus 2k pi all over n plus I sine into theta plus 2k or 2 pi k, whichever, all over n. Alright, so this is the general formula for finding the nth root of a complex number. Now there is also something very important I want you to understand, which is n in this case. Now since we are asked to find the fifth root, our n is going to be equal to 5. Now, if the question has said find the square root, our n is going to be 2. Again, if the question has said find the cube root, our n is going to be equal to 3. So in this case now, we are asked to find the fifth root, our n is going to be equal to 5. So in this general equation, wherever we find n, we are going to replace it with 5. Next thing now, our value for k is actually going to range from 0 down to n minus 1. And n minus 1 here is more like saying 5 minus 1, which is 4. So our k is going to range from 0, 1, 2, 3, 4. We stop. Alright, so these are the values of k, and this is the value of n. Now, to solve this problem, the fifth root of this complex number z is going to be r, which is the modulus, raised to power 1 over 5, because n is equal to 5. Now into cos this. Now this theta here is nothing but this angle you are seeing here, the argument. Now from the complex number given already in complex number, our r here is nothing but 12. So this is going to be more like 12 raised to power 1 over 5, since n is equal to 5. Now into cos, theta is the argument, and which is nothing but this 300 degrees you see here. So 300 plus 2 pi k all over n, which is 5. The same thing applies on this part. Okay, now the thing to be done is that we are going to obtain 5 answers. The 5 answers is going to be such that the first answer is going to be when k is equal to 0. Alright, when k here is equal to 0. Alright, the second answer is going to be when k is equal to 1. Alright, the third answer is going to be when k is equal to 2. The fourth answer is going to be when k is equal to 3. And the final answer, which is the fifth answer, is going to be when k is equal to 4. Very important. And of course, in all the answers we are going to be obtaining, n is going to be equal to 5. Please have that in mind. So no wonder we are asked to find the fifth root. Actually, the fifth root. All right. Okay. Now, solution here now. So now for k equal to 0, we are going to have that z raised to power 1 over 5 is equal to 12 raised to power 1 over 5 into cos 300 plus 2 pi into 0. So let me clean off this. You've already seen it. Into 0 all over 5 plus I sine 300 plus 2 pi into 0 all over 5. Alright, please have this in mind. It's very, very important. And what we're going to do is evaluating the whole of this. So this is 300 plus 0 over 5. 300 over 5 is something about 60 degrees. So, and evaluating this, we have 1.64. Alright, now cos 60 is nothing but root 3 over 2. Now, plus sine 60 now is nothing but, no, I think I made a mistake. Cos 60 is 1 over 2 rather. Then sine 60 is root 3 over 2. Of course, attach the I there. now this will multiply. Okay, so at this stage now, we have this. Now, if this multiplies this, we're going to have that this is finally equal to, now this times this, we are actually going to have 0.82 plus 1.42i. Alright, so 1.64 times half, we have this, and 1.64 times root 3 over 2i, we should be able to have that. So this is the first answer. This is the answer. This is the root when k is equal to 0. So let us put it here. Let us put it up here. So the first answer is nothing but 0.82 plus 1.42i. Now for the second answer. Now for the second answer, of course, for the second answer is going to be when k is equal to 1. So for when k is equal to 1, it means that the same thing, the same format. So we are just going to come here, put 1 here, then come here, put 1 here. Please, very, very important. All right, so doing that, we're going to have that. Now, evaluating the whole, so this is nothing like, this is more like saying 300 plus 360 all over 5. Again, 300 plus 360 all over 5. So whatever thing we have here, we take the cosine of it, take the sine of it, then now use this to expand and get the answer in the form of a plus bi. All right? Okay, so solving for when k is equal to 1, we are going to have that the whole of this now is more like, of course, this again still remains 1.64, all right, into now this is cos 132 plus I sine 132. I'm sure by now you should have noticed that whatever thing be the angle here must also be the angle here. Now cos 132 is nothing but, this is 1.64 into cos 132. If you press it, you should be able to have minus 0.669 plus 0.743i. Alright, now using this 1.64 to open out this bracket, you should be able to have minus 1.07716, alright, minus 1.09 rather, 09716 plus 1.218i. Alright, so this is it. Now, therefore, this is the answer when k is equal to 1. So that's our second answer. So it's actually minus 1.09716 plus 1.218i. Alright, so let's also solve for the third answer. That is when, now the third answer is going to be when k is equal to 2. Now for when k is equal to 2, it's just simple again. All what we are going to do is just to replace k with 2. So over here now we're going to put 2 here. We're also going to put 2 here. Alright, so now evaluating further, evaluating all of these things. So this is 300 plus 360 times 2 all over 5. Again, 300 plus 360 times 2 all over 5. So now for when k is equal to 2, when you evaluate all of these things here, 300 plus 360 all over 5, you should be able to have 204. So this again is 1.64 now into cos 204 plus I sine 204. So at this stage now, we're going to evaluate cos 204 and sine 204. And of course, when we evaluate this and this, then use this. Now, cos 204 times 1 point cos z raised to the power 1 over 5 is equal to 1.64 times cos 204 should be able to give us minus 1.498. Minus 1.498. Alright, then finally, now 1.64 times sine 204, we are going to have minus 0.669i. Alright, so this is the answer when k is equal to 2. So we actually have minus 1.498 minus 0.669i. Alright, so this is the third answer. Now, the fourth answer is going to be when k is equal to 3. All right. So for when k is equal to 3, what we are going to do is just very simple again, the same way we've been doing it. Just remove 2 here and put 3 here. Remove these 2 and also put 3 here. Then evaluate. Now, evaluating the whole of this now, we're actually going to have the whole of this now is nothing but 276. So this is 1.64 into cos 276 plus I sine 276. All right, such that when we evaluate cos 276, we use it and multiply this, or rather use 1.64 multiply this again, 1.64 multiply this, then bring out their answers in the form of a plus bi. Then we'll now list it again as one of the roots. All right, very, very important. So next thing now to be done is this 1.64 times cos 276, which will be able to have 0.17138. 0.17138. All right, so this times the whole of this, you should be able to have this. Now, this times this, you should be able to have minus 1.630 minus 1.630. All right, plus 98r. Okay, so this is the answer when k is equal to 3. So that is our fourth answer when k is equal to 3, which is 0.17138 minus 1.63098r. Alright? Okay, so the final one now will be when k is equal to 4. And for that particular one, I'm going to leave you to solve that one and tell me what you are going to have in the comment section below. And of course, the hint is just remove this 3, put 4 there, remove this 3, put 4 there, then evaluate and tell me your answer in the form of a plus bi. Let me know your answer in the comment section. So, my dear people, that is how to solve problems under nth root of a complex number. All right, just know the general formula, know your values of k, and again, know your value of n. Just apply this formula and you get your answers. Thank you.